I'm kidding.
Hello, everybody. Hello. Can you see us well? Can you hear us well? You can tell us that in the chat section at your right. Yeah. Hello, Rayed. Hello, Desiree. Hello, Azim. So many people. Each time it amazed me. Hello, Alexi. Hello, Andrea. Okay, so good. It's okay for you. Great. Well, we are very happy to have you. Thank you for joining us tonight in live for our SQL workshop. I'm gonna introduce myself. I am Lamia, Event and Community Manager at Le Wagon Paris. And around me, there is the amazing team that will run the webinar tonight. As you can see, I'm not alone. We are not from the same cities, as you might know, because this is a worldwide webinar. Some of us are in Paris or London or Sao Paulo or Lisbon in Portugal. And I'm wondering from which part of the globe you are. So maybe you can tell us that in the chat and put a little flag of your country. So from Valencia, from London, Montreal, London, Italy, so nice. Argentina, London, Mexico, Budapest. Okay, we are from every country of the world. And now I'm gonna present before starting this workshop Le Wagon for the people who don't know our school. Le Wagon is a school specialized in technical and intensive training. We started 7 years ago in Paris, and now we are present in 39 cities around the world. And we have trained more than 7,000 people to web development and data science. We have developed 2 intensive training courses. First one in 9 weeks in web development for people who don't have technical background with different profile as freelancer, entrepreneur, web designer, and people who want to change their career. It's a great melting pot of background. And recently we have launched our new intensive 9-week training course in data science, intended for people who want to go even further and become data analysts. Now you know a little bit about the Le Wagon. It's time to know the team who are here. So tonight, as I told you, I'm not alone. Here is the wonderful team that will be with you during this session, and I'm gonna let them introduce themselves. Maybe Joao, you can begin because you are gonna give the lecture as their lead teacher tonight.
Okay, so hi everyone. My name is João. So Portuguese, obviously. No one is called João without being in Portugal. So my background is in computer science and electrical engineering. I did the Le Wagon Web Development Bootcamp in Lisbon in 2016. And since then, I've been working as a freelance software engineer and also teacher at Le Wagon. Yeah, and basically that's it. And I'll be the host of your, I'll be the teacher of your workshop today.
Next one. Who want to talk?
Okay, guys. Well, my name is Ryan. I live in São Paulo, Brazil. My background is mechanical engineering, but I never liked the area, so I didn't want to work with the industry. And I did Le Wagon here in São Paulo about 2 years ago. And after the boot camp, I founded a software house. And today I'm CTO. I run a team of developers building projects and products in Ruby on Rails and all the technologies we learned at Le Wagon and some others. And I'm also a teacher at Le Wagon.
Well, I can go. My name is Julio. I'm from Mexico. I live in London, though. I did my batch number 222 in last year in January here in London. And I have been working in energy for some time. Then I was a product manager with all the skills that I learned. And I recently quit to create my company. And I'm teaching as well at Le Wagon.
Thanks for your. And now, Sarah.
Last but not least.
Yeah,
Hi everyone, I'm Sarah. I did the batch in January, so I guess I'm the freshest person here. I actually did Spanish and Portuguese at uni, and then I decided that I didn't want to be a teacher anymore and just sort of changed my life and learnt to code. And here I am. And now I'm a TA for the wagon, having completed the batch and doing some projects on the side as well. Really excited to be with you all.
Thanks everyone. So you know everyone, and before starting, few rules. First, as you know, Joao will give the lecture as the lead teacher for you for about an hour and a half. And Ryan, Julio, and Sarah will answer to your question. So please ask your question. To ask your question, use the section question at your right near to the chat. During the lecture, listen carefully. No need to take notes as takeaways because you will be onboarded on Learn then. And what is Learn? Learn, it's the e-learning Le Wagon's platform, where you will find the keynote of the workshop, the exercises, and the correction, so you can go further on your practice alone at home after the webinar. And last but not least, you will have a lifetime access to Learn. And on Learn, also you can give us your feedback of the workshop. It is very useful for us to have your feedback. It is very appreciated. And as we are doing many webinars, it is great to have your return to improve. Finally, also at the webinar, you will receive a replay link to rewatch the webinar right after the end. Enough of talk for me. Now I let the stage to this splendid team and to Joao. Have a wonderful workshop. See you. And Joao, I let the stage to you.
Okay, guys, so I will share my screen. Okay, guys, so hey everyone, so like Lemia said, so we're gonna have 1 hour and a half lecture. So there's no need to take notes, as takeaways will be in the platform. And you will have like 30 minutes, 40 minutes to practice after this mini introduction to SQL. And in the end, it would be actually great if you could give us some feedback, like Lemia said, so that we can improve with the next workshops. So with that said, today we're going to learn a little bit about SQL and databases. So let me just close this. Okay, cool. So this lecture will be divided into 2 parts. So the first one will be to explore and design a database, which is the type relational, so a relational database. And the second part will be about extracting data from a relational database. Okay, cool. So as an introduction, what is a relational database? So basically, when we talk about computer science, we have 2 major types of memory. So computer memory is generally non-permanent. Okay, so if you cut off the electricity of your computer while you're while you're having an unsaved document in Word, or while you're playing PlayStation, if you cut off electricity, you will lose all your data. And if you plug it again, it's not there anymore. So that's called volatile memory, which is memory that is stored in your RAM memory. But when you want to store information that it's persisted, so where you can cut off electricity and then turn it on again and it's still there, you can use another type of memory, another type of storage, where databases exist in that realm. Okay, so what is a relational database? So basically, a relational database, it's an organized collection of data. Models your data as rows. It's similar to a table in Excel. So each row will represent a record in your database. and then columns, okay, specifying different attributes of each specific record. Basically, relational databases are composed of tables, so multiple tables that can relate somehow with each other. Those tables will have fields and will have columns, so a bunch of rows and a bunch of columns. The tables will be connected through a primary key and the foreign key system that we're going to dive into in a few slides. So how can we connect the two tables together? That's the goal of this first question. So for that, let's model some data in an Excel file or a Google spreadsheet, which ends up being the same thing. So I have here my Google spreadsheet. And today we're going to model restaurants and reviews. So first thing that I need to do, so since I'm modeling on this sheet of Excel, I will call this sheet restaurants. So restaurant. So I will call it plural because I will have a bunch of restaurants here. So how can I model my restaurants? I think the zoom is okay, but I can zoom in a little bit more. Okay. Cool. So first thing that it's important when we're having a restaurant. So probably the name of the restaurant would be a useful thing. The address of the restaurant will also be an interesting thing to have. And also a category, for example. So we can have category here. So with those three columns, sets, let's add a few restaurants. So let me think. Oops. Okay, sorry. So first restaurant, we can call it Bel Canto. It's a Portuguese restaurant, and it's located in Chiado, Lisboa. Category, I don't know, it could be Portuguese. One second. So it could be Portuguese. Then we can add another restaurant. Let's have another one, Feitoria, which is another Portuguese restaurant. Boolean, and it's in Lisboa, and the type could be, I don't know, healthy, just to make it different. Let's add another one. So let's add Epicure in Paris. I think it's in this place. I will not pronounce it. Saint Honoré, or I don't know if this is even a district or something like that. But so let's add it like this. Paris. And this will be French. And let's add a few more. So let's add this one, Galo Oro, which is in Funchal, which is in the Madeira Island. And this will be traditional. And let's add more, a few more restaurants like McDonald's. Just to be a little bit different here. And where is McDonald's? So it's everywhere. So everywhere. And this is fast food. Okay, so here we're modeling our restaurants table. Okay, with three columns for now. And where we have the name, the address, and the category. But we also want to model reviews like we've seen on the slides. So let's go here. Let's open a new sheet, okay? And let's add the reviews table. So a bunch of reviews, so we'll call it like this. So reviews, for the sake of simplicity, we'll have contents. Sorry. We'll have a rating, and it will have nothing more. So let's add some reviews. So let's pretend that I went to Bel Canto, and I want to add a review to Bel Canto saying that it was amazing. So amazing, and I will give him its 5 stars, for example. And the problem here is that we have two tables, but they are not related with each other. So this is a problem. When we're talking about relational databases, which is like one of the major types of databases used nowadays, it's used everywhere, from web applications to data science. How can we relate the data between those two tables? What can you think of? What strategies could we use? So we have a name here, okay? So we can go here and, for example, do restaurant like this. And like probably, I don't know, like add here the name, Bel Canto. That would make sense, right? So this review is about this restaurant. So let's add another one. Not great, not terrible. Something like this. And the review will be 3. And this is McDonald's. Sorry for the ones who love McDonald's. Something like this. So now we are relating this review here with the restaurant McDonald's, but we are using text to relate them between each other. Okay, so there's a problem here, because imagine that someone added Bel Canto with lowercase b, so something like this, and now this doesn't make any sense because it's a different record, right? So the way we do it is by adding a unique column to our database, which will have unique rows. So the way we do this is whenever we are modeling a table in SQL, we need to add a column called ID, okay? And this column ID will have integers, okay, so numbers, and it will start always at 1. So for the ones of you who know how to code, normally when you're dealing with Python or Ruby or anything like that, arrays and lists and all of that start with the index 0. But in the database world, we start with the index 1, okay? So every table of your database should have an ID column to uniquely identify each record, okay? So the ID needs to be unique. The database will deal with incrementing the ID once a new record is inserted. So you don't need to care about it, but you know exactly that the ID is unique. So if we have this kind of structure here, to model our restaurants, we can go to our reviews and add the IDs. Every table needs to have an ID. So we can add this column and we can say that this is number 1, 2, and so on. Great. 4, and this will be this field here, this column here, will not be the restaurant text, but it will reference the restaurant ID. So in that way, it will be way more simple to connect the two tables together. So Bel Canto is ID number 1, and McDonald's is ID number 4, I guess. Let's check. No, it's actually ID number 5. So this one is to ID number 5, and this one is for ID number 2, which is Feitoria in Belém, Lisboa. So let's add another review. Really good service, and the rating will be 5 stars, and it's actually to number 2. You see? So looking at this, the way that I modeled our data, so each restaurant, we will have a restaurant, each row will be a restaurant. And now if you look at the second table, we can actually have multiple reviews from the same restaurant. You see, so those two reviews kind of belong to the restaurant with the ID number 2, right? And it's pretty cool to model this way. So let's look at the slides to see the example that we have on the slides. So on the slides, we have a bunch of restaurants here without the IDs yet. If we move, and when we have the reviews, but then when we add new restaurants, instead of using the text on the column, the D column, the restaurant text, we can use the ID. So basically we add the ID, which will be unique. It's the particularity of the ID. And we can actually add a reference on the reviews table for that specific unique ID on the restaurants table. So we can see that number 2 here, which is Alisher, has 2 reviews, very good and healthy here. Okay, so this relationship tells us in English that the restaurant has many reviews, or that the restaurant can have many reviews. Okay, cool. So let's talk a little bit about vocabulary here, because vocabulary is really important if you want to go online and search by yourselves and kind of develop more this skill on databases. So the vocabulary here is that a relational database is it's a system that stores records. Sorry. So this was confusing reading. Sorry. So each record will be represented as a row in the table, okay? And each row has a set of columns. Those columns are the attributes of each specific, in our case, restaurant. So the tables are connected together through a couple of primary key and foreign key. So this is the vocabulary that it's really important when you want to search by yourselves online. So if you look at our restaurants table, the ID will be called primary key. So this is the main key, and again, it's always unique, okay? If you look at our reviews table, the ID is the primary key, but the restaurant ID is the foreign key, okay? So we call these types of databases relational databases because we can relate tables with each other using a specific reference. In our case, we are using the restaurant ID. So we are using the primary key of the restaurants as a reference, and we add it as a foreign key to the reviews table. Does that make sense? I hope so. So restaurants underscore ID is the foreign key of this table. This is the primary key of this table, and the ID column is the primary key of the restaurants table. Okay? Yes, I hope so. Cool. So when we're modeling data, we have a bunch of different relationships that we can model between those two tables. So one that it's very common, it's one-to-many, exactly what we've been modeling. So in English, we can say that the restaurant has many reviews, or that the review belongs to a restaurant. So when we say that the review belongs to a restaurant, we automatically know that the review or the reviews table will have foreign keys of the restaurant ID, okay? Whenever something belongs to something else, that something has a foreign key of something else. So the review has a foreign key of the restaurant model. So yeah, basically it's that. So normally when you have databases, you will when you create tables, it's not on the scope of this workshop, but the database will automatically index the foreign keys and index the primary keys, so that it will be really performant and really fast to access all the foreign keys of all the reviews, basically. So if you want to check all the reviews of a specific restaurant, so those two, I want to check all the reviews of a specific the specific restaurant that has the ID number 2. The database will index, so the term, the syntax, the vocabulary, it's index. It will index those two, that column here, so that it makes the operation of checking reviews of specific restaurants really performant and with low latency. So yeah, cool. So the foreign key doesn't need always to be the primary key of the other table, but if it's not the primary key of another table, you should index that field. It could be the name, okay? But that name needs to be, it's a rule that that name needs to be unique, okay? So for that to happen, it's basically better to use IDs, okay? If you want, if the name is for sure unique and it's indexed on this reviews table, the restaurant name here is indexed to make it more performant. Yeah, it's okay to use the foreign key as a different column from the database. Okay, cool. So let's continue. So you have many to many. one-to-many relationship, which is one-to-n. So a review will have the foreign key of the restaurant. You have one many-to-many relationships and one-to-one relationships, okay? That we're not going to dive into it, but the most difficult one and the most maybe trickier to get, I think these concepts are quite simple, but this one is as tricky as it gets. You also have a many-to-many relationship, which is kind of a combination between many-to-one, one-to-many relationship, that if you understand this, if you understand that the foreign key will be a column in the reviews table, you'll be fine to understand the many-to-many relationship. So with that said, let's use this tool here. So the SQL designer to model the structure or the skeleton of our app. So if you can see, as you can see here I have data on my database, on my tables, okay? And what I want to do is to model my database with the skeleton. So I want to model the columns that each table will have. So that's my goal. So for that, I will open this open source platform. Okay, so you can go on this URL. So don't go now. You have the URL on our platform afterwards. So pay attention to this. So this tool here is helpful for us to design our schema. Okay, so schema, it's another keyword that you need to know, which has to do with the skeleton or the blueprint of your database. So let's model here our restaurant and reviews mini database. So the first thing that I will do is to add the table. So I'll add the table here. So I click that button and I click anywhere here, and I will call it restaurants table. So automatically when I add a table, it will fill in the column ID automatically, because every table needs to have an ID. So the restaurant will have a name. Let's not care about all of these other things for now. We'll have a name. We'll have what's more? The address, and category. So if you look at, if you look at this this example of a table, even if each of these fields that I filled in look like rows, they represent columns in our database. So this is a way of modeling our database. So if you want to build a web application, or if you want to start building or model your data set that you got online or anything like that, the first thing that you should start is with modeling your data. So model how the tables relate with each other. So without any data here, I define that my table restaurants will have those 3 columns. Okay. Again, so this is only modeling data, no data here. This is the skeleton of your database. So let's add another table. So let's call it reviews. And reviews, you'll have an ID, we'll have content, and we'll have rating, and they will have the rating. It's okay, and they will have the restaurant ID foreign key. Restaurant ID foreign key. So I have 2 tables with those columns, and I will click on the primary key of the restaurants, and I will do connect foreign key, and I will assign it like this, and it's fixed. Okay, so this is a great tool, open source tool, to model your database. Okay, so there's a problem with this tool, which is if I refresh this website, I will lose my information. So how can I store my information here? So I need to go to save load. Okay. And then click on Save XML. So it will generate this weird syntax here, which is basically another, it's kind of a language really similar to HTML. So it's a markup language. And basically this markup language will represent the table that you have. So one thing that you could do, you will have one exercise on the platform about this to see if you can model the database and then upload this code to validate it. So if we grab all of this, you need to copy it and save it into one specific file, okay? So I will copy it. Let's pray and let's hope it's copied. And I will refresh my browser. So I will quit this, refresh. Yes, I lost everything. So this is the default thing. So let's maybe delete this bit here. Okay, so it's clean. Okay, so now I need to save load XML. Okay, I need to paste stuff here. So paste what I've copied and now generate, oops, not this, sorry. I need to save and then I will do this, paste, and then load XML. And now we have our schema of our database saved. So the vocabulary here is that this is the schema. So it represents the structure of our database. So the blueprint, the skeleton of the app. Okay, cool. So you don't forget to copy the XML, save it into one file if you want to save it. So that you can open again the platform and load the schema again. Okay, cool. So this represents a one-to-many relationship, like I've showed you. So one-to-many, so a restaurant has many reviews, or the other way around, a review belongs to a restaurant. So if a review belongs to a restaurant, the foreign key of the foreign key will be here. Okay, the foreign key of the restaurant will be on the reviews table. Each of these rows represent columns on the real database. Okay, so no data here, no data at all. Okay. So you can save it as an XML or you can save it as text, whatever. The important bit here is that you can copy, that you need to copy the text, the contents, and then load them by pasting the contents. Cool. So I hope you understood this first part of the lecture. And now let's dive into the second interesting part of the lecture, which is about retrieving data from a database. So this is the important bit. Okay. So there are a lot of database types. Okay, so there are a lot of vendors or a lot of brands of database that you can think of. So three of the major ones are SQLite databases, Postgres SQL database, and MySQL database. Maybe you heard of MySQL or any of this, but those are really the most common. So Postgres, it's used by big companies. Those are all used by major companies like Netflix, Facebook, Spotify, Instagrams, all of that. They use a version of MySQL or Postgres SQL. So SQLite is not that used for production. So production means when you upload your website online, okay, not the development environment, which means while the website is, or the web application or your machine learning model, it's still in your machine. So SQLite is not that used in production. It's more used while you're developing your app. SQLite is also used as kind of an offline database for mobile applications, for Android apps or for iOS applications. So cool thing about SQLite is that all the tables, instead of like Excel, instead of like this, well, we have multiple sheets for each table. On SQLite, we have all the tables in one file. That's one particularity of SQLite databases. So even if you have 100 tables, you will have only one file with all those tables and the connections and the relationships between those tables. Okay? Cool. So in this part of the class, we're going to look at this website, Sqlite Online, and play around with the restaurant SQLite database. Okay. So let's go here. I downloaded the file already, so it's this one here. Okay, so the way this works is by going, you can go this is open source, it's free. You can use this to play around and to practice. So what I did is I did OpenDB and I opened this restaurants SQLite database. You see the extension is SQLite, so it means it's a database. It doesn't mean that it only has the table restaurants. It means that it can have a bunch of other tables. So the restaurants, it's the name of the database itself, okay? So I did open. I will not open it again. I think it's opened already. So when you do open, you will have this platform understands all of those types of databases. Okay, so we are using SQLite. You can also use Postgres, MySQL, MariaDB, which is another database type. So on this SQLite, you have those three tables. So it automatically read the file and understood that it has three tables stored in that single file. So those three tables are restaurants, reviews, perfect, that's what we want to play around. And then it has this SQLite sequence. This is like for internal workings of the SQLite, so we don't care about this. So we only care about those two types those two tables, sorry. So let's look at the slides for a bit. So loading, opening the file, the SQLite file, like I showed you. You need to download the file. You're going to have one exercise about movies, about the movies database that you can download from the platform and then load it to this website. And yeah, okay, cool. So to dive into this second part of the lecture, it's important to know the language that we're going to use to query the database, to get information out of the database, okay? So for that, we're going to use SQL. So probably you heard about it. SQL stands for Structured Query Language. It's tech from the 70s, so it's pretty old. It has a lot of research behind it, so it's really robust, really performant. So it's tech from the 90s, developed by the IBM labs in the United States. So this language is used to query the database, and it's really kind of different from a normal traditional programming language like Python and Ruby and JavaScript, because it specifies that the result that you want. So you don't need to specify the way to get to your result. You can go in and say that and specify the result form that you want. So it's declarative. You don't have variables. You don't have loops and anything like that. So it's kind of more high level than normal programming languages. And basically, it specifies what is to be done rather than how to do it. So that's one of the big advantages on SQL. Okay. Okay, so let's look at the syntax and the vocabulary here. Okay, so if the question is, give me all the restaurants and names from my database. Again, our database is exactly this. Okay, so this is the structure. So restaurant has all of those columns and the reviews have all of those columns. Actually, they have a little bit more. So the first question is, give me all the restaurant names. So let's go here and maybe zoom in a little bit. Can you give me some feedback on that? Zoom? Not? It's okay? Select. Okay, I think it's okay. Zoom good. Nice. Thank you, Martha. Okay, so select all the names of the restaurants. That's our question. So select, we need to, the syntax here is select, and then we need to specify the column name. Okay, so the column name. So this is the syntax from the table name. Okay, so of course this will give me an error. sorry, but this is the syntax. So select the column name or multiple columns. Okay, so column name 1, column name 2, etc. from the table name, and it will select those columns from the table name. So this is the syntax that you need to memorize on how to read or how to question your database. This is reading from the database. So I want to check the column name, right? The column name and the name of my table. If I look here on the left, it's called restaurants, plural, restaurants. So I do this. Traditionally, you went with a semicolon on your SQL query, and now I press run, and I get this result. So it's kind of a sub table of my main table with all the restaurant names from my database, which is pretty huge. You can look here that it's has a bunch of restaurants. Okay, so what if I want to select all the columns without typing all the columns? There's a shortcut for that, which is the asterisk. So if I do that, you can see that each restaurant has a unique ID. So let's see. So it has a name, it has a cuisine style, it has a city, and it has a rating. Okay. So this rating here that we didn't model, I think it's the average rating. So let's forget about the rating because the reviews have the rating. So let's not care about that. So ID, name, city, and cuisine style. That's those are the major columns that we are interested on. Cool. So this is the first question. Give me all the names from restaurants. It's basically select the column name from the table restaurants. Cool. So give me all about restaurants. Give me all the columns about restaurants. Okay. Give me all the Japanese restaurants. So obviously, let's not do the Japanese. So give me all from restaurants. Okay. So it's kind of like we need to filter this subset. So we have here a table with all the names, right? So not all the names, but all the columns with our restaurants, but we need to filter this. And to filter that, we need to use the keyword where in SQL. So we use that, where, and then we can say that the column cuisine style, okay, it's equal to a specific string. So if we look, or a specific text. So if you look at this column here, cuisine style, we have a bunch of different cuisine styles, Japanese, Spanish, Italian, and so on. So I want to filter where the cuisine is Portuguese. So if I do that, I only have one. Oops. I only have one, which is this one, which is in Lisbon, and it got filtered. So if I do Japanese like this, I get all the restaurants where the cuisine style is Japanese. So one particularity here. So if you are used to other languages, so other programming languages like Ruby or Python, you know that this operator is called the assignment operator. So normally when you use this operator, you're assigning a value into a variable. So normally you read this from right to left in other languages. So you're saying that this text will be stored inside this variable, but that's not true with this with SQL. With SQL, for the ones who know how to code, this is equivalent as using the double equals. Okay, so it's a comparison. Okay, so I'm saying that I want to select all the columns from the table restaurants where the column cuisine style has the value Japanese. So no assignments here. There are no variables, nothing. Okay. So it's kind of a filter, okay? And you can use logical operators like Boolean operators like and or to kind of add things together. And the column CT is equal to Oslo, something like this. And then I get this one, okay? So you can mix things together, or you can use or. So it will give me all of them or the CT Oslo. So yeah, cool. So let's play around with more. So give me all the restaurants that are called Café in Paris. So something cafe or cafe something. So that's our goal. I don't know if you understand the question, but maybe if I get lucky, we can see some cafe here. Yeah, we can. So in Edinburgh, we have a name of a restaurant that ends in cafe, okay? But there are a few of them in Paris that start with cafe or have cafe in the middle, or cafe in Madrid, Café del Monaguillo, something like that. Okay, so we want to get all the restaurants that have cafe in the name, basically. So how can we do that? So select all from restaurants, and now we need to filter it, like where name, and we say name equals something. But since we want to filter, we can say name like, okay, because we're using text in this case, and we want to use a special operator that I'm going to show you. Where name is like cafe. So if I do this, well, let's see what happens. So cafe like this, it needs to be exactly the same for it to match. So nothing happened here. So there's no restaurant with the name only cafe. There's only restaurants with the name cafe something, obviously, or something cafe, right? So the way we check this, so let's see all the restaurants that end in cafe. So for that, we use this special operator here, okay? And we can check all the restaurants that end in cafe. You see? There are a bunch of them that end in cafe. What about, I want cafe somewhere in the middle of the text. So maybe they end with cafe, and the cafe has some text in the beginning, which is represented by this special character, and some text in the end. So now we get all of them, okay? Cool. But we want to get all the restaurants that are named cafe in Paris. So for that, let's use the Boolean, let's use Boolean Logic, and let's say that the city needs to be, the column city needs to be Paris, something like this. And now we get all the restaurants that have cafe somewhere in their name that are from Paris. So if I delete this here, sorry, if I delete this here, I'm hoping that it gets those two restaurants, the ones that start with cafe, and that's it. Cool. Are there any restaurants in Lisbon that have cafe? Yes, there are. Okay, cool. Cafeteria, very nice. So it doesn't even need to have a space, this with this character here. It's kind of a subset of text. Okay, cool. Another question. Give me all the restaurants ordered by rating. So the restaurants, like I told you, have a numbered column, which is called rating. Okay. So basically what we can do is to run it like select all from restaurants. Let's delete this. Select all from restaurants. So selecting all from the restaurants, all the columns, and then I want to use this keyword. So order by, I want to order by a specific column. What is the column? It's rating. So if I order by rating, and if I go to the right, you can see that it starts with, this doesn't make any sense. Okay, so let's forget this. Why is this in our database? This is weird data, but it's ordered by default in ascending order from lower to the highest value. So we want to order it in a descending order, right? That makes sense. And then limit to the top 3 to show it on our web application, or because we want to apply any algorithm with only the ones that are the top 5. Okay. Cool. Nice. So this is just an example. Cool. So another question. So how many restaurants do we have in our database? So if I do this, I have no idea how many restaurants do I have. So for that, instead of selecting columns, I need to use a special SQL function. So They're called aggregate functions, okay? You have a bunch of functions in SQL, like count, mean, max, average, sum, things like that. And for that, oops, and for our use case, we're going to use count. So let's use count. Let's do count. We need to type it like this. We need to count. This is the syntax, okay? So it's like counting all the columns, which in our example makes a lot of sense. But in some other more advanced stuff, you can select specific columns. But when I do this, I can check that I have 942 restaurants in my database. So it's not that small and it's not that big, but has a lot of information here. Cool. What if I want to count all the restaurants per city? So it's the same thing. I would be, I need to count them, but I need to kind of aggregate them by city. It's like I need to go through the list, and when I see a restaurant from Lisbon, I add to a specific bucket. When I see a restaurant in Porto, I add to a specific bucket. When I see a restaurant in Paris, I add to another specific bucket. So how can we do that? So to do that, we need to first select the count, the function count, and also select the name of the restaurant. And and for that, after we count, to add to those buckets, that analogy that I told you, we need to use a special keyword called group by. So we need to group by. What column do you want to group by? We want to group them by city. Sorry, this should be city here. Selecting the city and the count. So if I do this and I run it, you can see that I have a count for all the restaurants in my database on each city. Cool. So yeah, nice. So whenever you use counts or any of the aggregate functions in SQL, so an aggregate function is basically a function that performs some calculation on a set of values and returns a single value, like count, performs the count on many values and then returns only a single number. And aggregate functions ignore values that are not there or null values, and aggregate functions are often used with the group keyword. So basically, whenever you use a function, count, max, average, mean, you need to use the group by keyword also for it to make sense, okay? So basically, aggregate functions is a function where the values of multiple rows are grouped together as input on a certain criteria to form a single value or a more significant meaning. Okay, cool. So now I want to count all the restaurants. So this information is good, but it's not sorted, right? So I want to sort them by the highest restaurant count to the lowest. So how can I do that? So I select those two things, a column and a function. And after I do the group by, I need to order by, and I want to order it by the count, right? But I cannot call the function here. So what I need to do is to kind of do an alias for the function, like it's like assigning the function to a variable. So I can do as, and I can name it whatever I want. So ABC, for example, it can be ABC. It can be something that makes sense, like count, not count, but counter, something like this. You can name it whatever you want, and then order by, and then I need to call that variable, okay? It's like we are defining the function or this function here. Anytime you want to order by it or do a where or something like that, or not aware but having or something like that, we need to call it this by this variable. So we need to order by counter, So if you run this, by default, it's ascending, like I showed you. So we need to call it descending. So show which ones have the more restaurants. So it's London, and then Paris, and then Barcelona, and so on. Cool. So let's look at the slides for a bit, because I don't know if I'm moving fast, but okay. So give me all about the restaurants. Select all from the restaurants. Give me all the Japanese restaurants. So select all from the table restaurants, where this column here is equal to the. It means that where this column here has the value exactly like this, Japanese, capital J, and so on. If it's lowercase j here, it will not work, because if you have a mix of data in your database, it will not work. So it means that you don't have the data structured. You should have like the data really structured for you to be able to perform these reading queries and to get information that makes sense, to get real insights from your database. So give me all the restaurants called Café in Paris. So this is wrong here, right? Because it starts with Café. So if it starts with Café, you don't need this percentage in the beginning. So there's a typo here, sorry for that. So select all from restaurants where the column name is like Café. So the text Café somewhere in the middle of the string. And the column city has the value of Paris with a capital P. Cool. Give me all the restaurants ordered by rating. So order by gives us, by default, ascending order from lowest to highest. So to do that, we need to specify the descending order. Select all the columns from restaurants, order by rating descending. You don't need to use the asterisk here, right? So you can select any columns that you want. The table will be filtered. So when I do here city and count, I can do city and address if I want. I'm selecting a bunch of columns. No, I can't. No such column address. Where was the column? Sorry, guys. It's columns city. The address is the city, so it's the name. So I can say here name. Okay, so now I have two columns, and on this order, right? So if I pass the count to this side here, count, and I do count as counter, and then I do comma, and then the second thing is this, and I delete this, and I run it. So now the counter is the first one. So the select, the order of the columns is the order that you're going to get. If you're kind of reading this information after you do the query, you read this with another language like Ruby or Python or any other, you're going to have kind of a list or an array with the columns in this order. So you need to access the elements on that specific order. So that's irrelevant here, okay? But normally it makes sense to have the count in the end, I think. It's easier to read. But yeah, cool. So this means all the columns, basically. How many restaurants do we have? So in this case, we only want a number. So we use the aggregate function, no group by, no nothing, because it doesn't make sense to have a name column when you count all the restaurants. What would be the name? Doesn't make sense. So select the count from restaurants. This will give you a number. So if you do this and that, it will give you just a number. It doesn't make sense to have a name. The name doesn't, you can do that, but it's an error. It doesn't make any sense. This will be the name of the first one on the database or something weird that doesn't make any sense. Swarna, which is the first one, you see, doesn't make any sense. So whenever you want to count all the elements, you do it like this. Count all the restaurants per city. So you select the city and the function counts, and then you group it by the city. In this case, it makes sense because you're grouping by the city. So city, and then group by city, like I showed you. And now we have this. And then we did order by counter descending, and counter doesn't exist, so I need to do as counter. It counts. Okay, so Lana has the most restaurants. Again, this was the last example. Cool. So count all the restaurants per city, then sort them. I just did that. That's the most difficult bit here. And that's it. So cool. So let's dive into more advanced queries using those tables. So until now, we used only the restaurants table, right? But we also have the reviews table. Let's look at the reviews table. So the reviews table has all of these columns. So it has this column here, restaurant ID, which is the foreign key to this table here. So if I do, from what I've learned, select what columns do I have? All, let's do all. From reviews, and I run it. Okay, so now I have reviews. Cool. So this is just placeholder text. We don't care. So it has all of these columns, and it has the restaurant reference. So it's referencing the ID of the restaurant. Cool. So for more advanced queries, since we have a relationship between tables, we kind of can connect or join the tables together when a specific value of a specific column is the same of the value of a specific column on the other table. So it's kind of a match between values in the columns. So I want to select all the reviews from restaurants. From a restaurant, from the restaurant with the ID, this ID 26610. I want to get all the reviews. So basically what I need to do is to join this table with the other one, where this foreign key is the same as the ID column on the restaurants table. So that's exactly what we're going to do. So the syntax will be, we do select column names from table name, right? And then we use another keyword, which is a little bit more advanced, which is join. Then join what? Join the table name, the other table name that you want to join, on what? On what relationship? What is the relationship between those two tables? So on a specific column, so I don't know, like this is table 1, this is table 2. So on table name 1 dot the ID column, where the so join the two tables on the table 1 ID is equal with the table name 2 dot in our case restaurant ID, where those two columns match basically. So that's the particularity of these types of databases, is that the tables are related with each other. So it's called relational databases. So you can use these types of queries when you want to fetch information from a bunch of tables that are connected together. So imagine that you have a skeleton or a schema of your database that has hundreds of tables or dozens of tables. So with this kind of syntax, your queries can be pretty big and pretty complex, but the simple concepts are always there. So the logic there, it's always the same. Okay, you need to join tables where specific columns match other specific columns. And since you have structured data, it's easy to match them together. So that's why we use a lot these databases. So having this syntax in your heads, okay, so with the join and the on, let's see if we can get all the reviews from the restaurant with the name Telepizza. So my goal is to get all the contents of the reviews from the restaurant called Telepizza. So let's do it. Select. So I want to select what? I want to select column name. So if I'm joining tables, imagine that the table restaurants and the table reviews have the same column, because that's possible. Imagine that instead of content in the reviews, I had name. That would be a conflict. So I need to specify the name of the table before, restaurants.name. So this is the column that I want. I want to select this column and the reviews table dot content. The other examples, I didn't use this syntax because I was selecting from only one table. So I want to select this from, you can specify here any of the tables, okay? So in my case, I will say restaurant, the order is indifferent. So restaurant, and then I'm joining with the table name reviews, and then I'm joining them in what condition? I'm joining them where this column here is the same as the restaurant's ID. Okay, where this foreign key is the same as the primary key of the restaurant. So I would say restaurants.id is equal to the reviews dot restaurant ID. It may be a little bit confusing. So this is the column name of this table, and this is the, so my mouse is, this is the column name of this table, which is this one here, where this column is the same as this one. Okay, so if I run this, I have, so let's do, instead of this, let's do all. So if I have this, it's like I'm really joining the tables on a specific value. You can see that the first 1, 2, 3, 4, 5 columns belong to the restaurants table, okay, where you have the ID. Memorize this, so 266110. So if I go, so this is the ID of the review, the unique ID of the review. So 26610, and then I will go to the right, and then the restaurant underscore ID on the reviews table is 26610. So it's joined where those two columns meet, okay? So that's the relationship here. So we have a bunch of, since we did this query, we have a bunch of columns that we can select, kind of filter it. So in my case, what I want to do is to filter them on the restaurant's name, so restaurants.name, like I did, comma, and the reviews dot content, right? So reviews content, it's here. So the reviews table, so the restaurants table are the first 5. The reviews table start with this ID here to the right. So now if I run this, I only selected those 2 columns from different tables, and I can see that this restaurant has this content, and so on. Probably here, I'm not sure, but there are restaurants with multiple reviews, so the name will repeat, okay? But they are not like one next to each other. Okay, cool. So our goal was to get all the reviews from the restaurant called Telepizza. So after we get that, we need to filter the restaurants just to check exactly what I was saying. So where restaurant's name equals Telepizza. So something like this. And now we have this. So we now have one review. Cool. You can also have all if you want, instead of selecting all the columns. So let me check where restaurant city equals Lisbon, for example, to see what we get. Any reviews for restaurants in Lisbon? Yeah, we have. So we have a bunch of restaurants here, and those will be the reviews to those restaurants. So even if the restaurant can have multiple reviews, we don't have multiple reviews here. Okay, cool. So this is the syntax, okay, with the join. You can also get all the stuff, all the columns, if you prefer. So those are all in Lisbon because I filter them, and the reviews are these ones. Cool. Okay, nice. So the last query that we're going to do is count how many reviews do we have in Lisbon, for example? So how can we do that? So instead of doing this, we do count, in this case. And if we run it, we have 13 reviews in Lisbon, okay? Or if we want to check them in Paris, we have 48. Cool, nice. So I hope you took something out of this lecture, not this workshop. So the core concepts here, as a recap, is that relational databases are really used nowadays and since the 70s. It's tech that is has a lot of research behind it. It's really performant, really robust. Everyone uses that for real in production. Facebook's, Instagrams, Spotify's, Netflix's, everything, big companies, everything uses this kind of databases and other types if it depends on the specific requirements. And to query databases that are relational, we use SQL, which is a language, which stands for Structured Query Language. So it's a language that it's declarative, where you specify, where you don't need to specify how to do the path to get your result. You just specify how do you want your results to be. Like you see here, it's very declarative. And basically the tables that you have in a relational database are related because columns relate with each other through primary key, foreign key pair, okay? So you have a foreign key in one specific table and you have a primary key on another specific table. Whenever you have a foreign key in a table, it means that that model, that table, belongs to the other table. So the foreign key in our case is in the reviews table because a review belongs to a restaurant. So a restaurant has many reviews. Okay, cool. So let's do another one really quick. So let's select, for example, all the restaurants that have a review that it's greater than 3, because that could be a business problem that you want to solve. As a developer or as an engineer, you want to give that to your marketing department or anything like that. So to keep it, but this is a simple example, obviously. So we do restaurants, restaurants.city, and then the count from restaurants, join those two together. Where the city is Paris, because it has 48 reviews, so it has a little bit more to play around. So let's not do the where, let's group them because we are using a count. Let's group by the restaurants.city. So if I run this like that, I have all the reviews. All the restaurants, it's not city, sorry, city, and we can also do reviews, restaurants.review. I think it's rating. Yeah, it's rating. So if I do this, I have 3 columns. So this doesn't make sense. I want to group them by the rating. So group by the, actually, sorry. I want to group them by the city, and now instead of using where, I'm using this keyword having, because I'm using a group by reviews. So this doesn't make sense. Reviews. Sorry, my mouse is dying. So let's remove this one. And let's do select the city, the count from restaurants, join the 2 tables together, group by the city, but having the reviews dot rating, because we don't care about the column rating in the restaurants, greater than 3. Cool. So here we have the cities that have the most views greater than 3. So guys, I hope you learn a little bit like this, a little bit about SQL and relational databases. So let's look at the platform. So it's this one. Oh, guys, sorry guys, I didn't have it open. Where is it? Okay, so it's this one. So you have here some exercises. You have a video, but it's in French. If you know French, it's good, but if you don't, we don't have the content yet in English. So we have here the slides, all the slides that I've showed you. And then you have here some exercises. So you see that we use the platforms that I've been showing you with the XML and all of that, DB design, DB database schema. You need to upload here your XML. So we have these exercises and you have some takeaways. So the takeaways are really important if you want to kind of consolidate what you've learned from this workshop. You have some information here. And you have here some flashcards, okay? So you can take this quiz. So what does SQL mean? So it's a structured query language. Relation database is, it's not a table containing, it's a connected tables of records. Primary key, it's the ID of the record. So this one has multiple correct answers. And the unique identifier. What is a foreign key? It's the ID, no. It's a reference to a record from another table, no. And it's not, no passwords here. So select the right answer. So you see here a relationship, a more complex relationship. So a director has many movies. A movie belongs to a director. A movie has many movie genres. So this is another table. And the movie genre belongs to a movie. So this is how you model, instead of doing one-to-many, you model many-to-many, okay? You need what we call a joint table with 2 foreign keys there. So a movie has many movie genres. A movie genre belongs to a movie, and also a movie genre belongs to a genre. So this way, with those 3 tables, you can model a many-to-many. So this can be a little bit more complex. You can dive into that if you want to know a little bit more about it, but the joins are the same logic. So a genre belongs to a movie. A genre belongs to nothing. So a genre ID is the foreign key of movie genres. A movie has many genres. A movie has many genres. And a genre has many movies. That's the particularity of this table. It's many-to-many. A genre has many movies and a movie has many genres. So this is correct. Movie ID is the primary key. So when I see movie underscore ID, it's no primary key. A movie has many directors. No, a movie belongs to a director. ID is the primary key of directors. Yes, it is. It's here. Cool. How do you find all the genre names? Select all from genres. Genre names. So we need to select all the names, the genre names from the genres, not all the columns. Okay, how do you find the number of directors? Count. So this is a syntax error. So it's count. How do you find movies released in 1999? So all movies where year equals that, where like you don't specify here the column, so it's this one. And how do you find the movies directed by Angelina Jolie? Did she direct any movies? I have no idea. So, so select movies title from movies, join with the other table, and then where the director name is this one, or the director ID, which is a number, is that one. It's this one because it needs to be text. And now this is a little bit more complex. This is a many-to-many, and I want to do what? How to find the number of zombie movies. Okay, so select count, genre names, and genre names as genre names. So we are kind of doing an alias here. Then join on those 2. Movie genres, movie ID makes sense. Genres.id, movie, yeah, this makes sense. Genres name equals, so the column name of the genres table is equal to zombie group by genre underscore name. Okay, makes sense because we had an alias there. But this one doesn't make any sense because we are joining the genres on genre ID underscore ID. Where is this defined? Genre underscore ID. We need to specify the table before. Table dot something like this one. So this is correct. So let's see. Yeah. So you can take the quiz. I know I moved really fast because we want to give you time for the exercises. So after that, give us some feedback about the workshop and read a little bit more about our bootcamp, especially our data science bootcamp that we are launching in a lot of cities, including Lisbon. Okay, guys, thank you very much. And just click on that link to follow the next steps. Oops.
So this is the end of the workshop. Thanks everyone for your time tonight. It was really a pleasure to have you. Now you will have all the material on Learn, our e-learning platform. You will find the keynote of the workshop, the exercises and their correction. You can go further on your practice. And as I said at the beginning of this webinar, you will have a lifetime access to Learn. Also, please give us your feedback. It is very useful, as I said. It is very appreciated, and as we are doing many webinars, it is great to have your return to improve. Finally, in few minutes, at the end of the webinar, you will receive a replay link to rewatch this workshop. Also, we have many different webinars with many topics. Don't hesitate to join us for next month. You can find them on our website. And thanks to this amazing team, you were perfect tonight as usual. Thanks for your help. Thanks for help the participant tonight. Have a good evening and see you soon. I hope to see you soon. Thank you, everyone. Bye.
Thank you, everyone.
So in few seconds, it's going to be the end.